pretty informal.
Put this on hold, welcome everybody, and thanks for coming down to look. I'm a machinist, and basically I'm not a machinist, I'm a fixer, and I do a lot of machining as well. I'm a tool maker, fitter, turner, electrician, all of those things, 50 odd years of experience. I've worked in the mining industries, and oil and gas, a wide range of projects. And part of my business is what I call the getter out, or getting broken bolts, broken studs, stuck into anything like that, either in my shop or on the mobile. I have a vehicle with a crane, fully kitted out, and I go to sites and I've got 2 strip threads in a vehicle with either a garage or a private person or in a machine, something like that. I go out, I do the job, get the fastener out or whatever it is. I then do a thread repair to bring it back to well, as close to spec as possible. I can't guarantee any old castings. You never know what they've been cooked and so forth. I want to show this is the entrance to my shop. That's just a few jobs there waiting in my shop. And there's a big span there of submersible pumps, all different parts of equipment. And that's what I call my waiting room. I don't have enough room in my shop. My shop is probably less size than this. I've got a lathe, 2 milling machines, a horizontal borer, a grinder, 2 cutter grinders, electric pedestal drill, and so forth. And then all the hand tools and so forth. So we're moving along quickly because there's a lot of activities going on. So that's my vehicle. It's what we call in Australia a ute. It's a 1-ton truck, and I have roller drawers there. I can pull those roller drawers out and go to and take my tools to the job. So I cover quite a range of activities, and with the getter out business, we've got what does the customer want? What does he actually need? Does he want me just to pull the bolt out and then he'll fix it, or whatever? And that needs to be determined before I go out on the job. Then I don't want to hang around. I just want to get in there and get it done. A lot of people talk about heat as far as getting bolts out. We put a nut on it, we weld the nut, we TIG it, we get the heat in there, that'll shrink it, that'll break the thread. 95% of what I take out, I can't put heat to. Whether it be in an engine block in a very difficult area, or whether it be oil and gas. You'll see here some very exotic pieces of equipment that come in. Some of those bolts are 40 by number 4 by 40 threads. Stainless steel, high tensile, inside of stainless steel, high tensile housing. So you can't use heat there. You've got to use other options. And the options are many. They start with drill bits, left-hand drill bits, carbide drills, carbide 2-flute drills, carbide milling cutters, and then from there also to carbide BARZ, both of the small size and the large size.
Congratulations. Contest with Joy. You gotta go give him a prize.
Excellent.
I'm gonna stop this entire
Anybody who doesn't know, this is Jim Zastro. He
just won James Coer Challenge.
Yes. And also, he was the recipient of the first What's in Your Box by Keith Benny.
I need him. I'm sorry, Bruce.
Go. We've got to keep moving on. So there's all the financial considerations that people are going to say, well, how much is it going to cost to take the bolt out? I've no idea. My crystal ball's got 10 cracks in it. I've got no idea. So it's horses for courses, and when you get there, it's whatever is required to do it. And then people see me grafting away for an hour or 2 hours, and they say, we couldn't do that. Where'd you get the patience from? 48 years of marriage. Yeah, so this is my thread surgery. We got bolts, we got taps, of all different shapes and sizes. There's plenty of them here. These here are broken easy out, as you can see. Then there's all sorts of other bits and pieces. Now the tooling, the threads that we deal with, metric standard, metric fine, ultra fine, metric 1mm series, UN standards, UNC, UNF and other pinches. We've got UNJ, which is mil spec, NPT, BSP, watchmakers, buttress, Acme. In fact, we've got the watchmakers here, I'll show that to you later. Then the tools I use is drill motors, die grinders, angle grinders, carbide throughput, and all of those things. Heating, freezing, I use freezing quite a lot. I use the electronic freezing cans, and that goes down to quite a low temperature. And sometimes I can drill and grab it with a easy out, and then spray it with the freezer and get it out that way. Sometimes I use vibration, tap, 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 tap. I've had a motor, an old Fordson motor that was underwater. The block was underwater for 5 years. They brought it to me with these long bolts to get it out. That was 5 days. Every time I turned around, I'd tap those bolts. I got them all out that way. Yeah, so we got all that different types. We've got boroscope, very small ones, dental tools. I buy these dental tools. I have 2, I've had for 50 years. I still use. Carbide insert center drill is an excellent tool. It's a center tool that's made for centering on the lathe or in the mill. But it's a carbide replacement. It's got two cutting ends on it, and that's excellent because it's also got a round radius, and that provides you with a good entrance in. One of the tricks, it's a small instrument, but one of the tricks that I use, one of the basic tricks of getting anything out is to find the center. The center is the key to having a good, efficient removal of bolts. So the other thing is I try to get to the surface. So if the bolt is protruding out that much, and I know I can't get it out, or somebody's already tried a pipe wrench on it, I will grind that flat. So right down to base metal, so you can actually see the top of that thread. And then I'll take a die grinder with a ball nose grinder, and I'll grind out and I'll make a dimple in there. Then I'll follow through, not always, but I'll follow through with a center drill and drill down until it's actually picking some of those threads. Then the next step, always, is to drill a small pilot hole all the way through till you felt it's gone out the other side. Because then you know what the depth of the problem you've got ahead of you. It may only be 2 threads, but it may be that thing. When you're down inside of an engine, some engine bolts, some of them could be 5, 6 diameter lengths of broken bolting. So there's a small interest in it. Another thing I have is this little mag base tapping handle. That's what I use for centering up, making sure we're getting a great start. Because the other thing, the other tool that I use all the time, I have a very small squares, 2 inch by 3 inches, even smaller than that. I use that to, when I'm drilling, to line up the drill bit, to make sure that it's that I'm on song as far as straightness is all the way through. I'll drill a bit, and that might be up on my head or wherever, and sometimes you can only use the leaf, because it's got a nice square edge on the end of it. You can't use the actual hole. That's it. Then you've got all sorts of different drill guides. Now I make many of these drill guides. What you see here are all ones that I've made. Some are blocked with a slot. So, actually, where's this is a block with a slot with different holes in it, and every time I need it, I'll drill another one. So that I can put on a block on the head, and I can find the position I want, look down through there even with the borescope or there, find out where I am, and then lock it in place, and that's my guide. I've got drill guides here, I've got tapping guides, and I also have here for crankshafts. Quite often I get called out because the crankshaft's got a broken bolt in it. Now, you just can't attack that crankshaft and drill that hole. Sometimes the bolt's in that deep, sometimes it's right at the edge. Generally the thread's deep in. So what I do, I have about 8 of these crankshaft adapters that I've made. I've machined it with a keyway slot in it to go over the keyway, so quite often that crankshaft will have a keyway. And a drill guide, a large size and a small size. I slide that on after taking the balancer off. I slide that on, I then lock it in place with a grunt screw, and that's my guide to drill through. I'll then take that off and put the larger one on, the larger hole one on, and I'll slide that in, lock it in, and then I'll drill it out. And if I feel it go like that, I know I've got it. I'll then take a left-hand thread, and a left-hand drill, and I'll try and pull it out with the left-hand drill. Or I'll use an easy out. So there's some of the tools I use. Here we have straight flute carbide drills. These ones here, they've got a shallow point to them. They're solid carbide. They're very brittle. There's a couple of different ones here. So what you're seeing here is all carbide drills. They are very good for getting in and breaking out the drill tab. That's some of my kit that I've rolled in underneath a truck that I've been called out to do a truck pull out. This is a time cert guide kit. That's actually a proprietary one you can buy. But nearly all the 4-cylinder, the 5-cylinder aluminium block vehicles have the F11, and these are all F11. They're complete. It's got a drill with a sliding guide. Let's see where that.
It's in that box.
Is.
It's in the big box. On your right. On your right.
Your big box.
Yep.
Yeah. So it's got a drill. It's got a reeler. It's got a long tap. And it's got a end point. So that is a square one that you can make. So it's a square block of 3/4 inch aluminium. Aluminium, notice that, aluminum doesn't work. And so, and it has 2 large holes and a small hole, and a set of nuts and bolts that go with it. So you can drop it over the block, and you can screw 1 and 2 screws in. Another one's got a guide that goes down, and then you've got a sliding guide that you go down into a hole and lock it in. The 4th hole is where you're actually drilling and tapping, and you can slide in a little block guide, and then you can drill that out, and the drill is a step drill, so it'll drill through the thread, and then it'll drill the new pilot, and then you can follow through with putting the insert. Then this is a big cert counterbore. We'll set this around. This is I've only got a time cert here. But the time cert is a solid insert, and that solid insert has got a bit of a head on top of it. And the way these are applied, you have an applicator that goes in. Once you've cut the thread and you've done the counterbore so that will be below the surface, you then put in the applicator. Now that applicator is not round. It's sort of has a funny shape to it, and as it screws down inside, it expands this out and locks it in. And that's these are quite expensive. The whole kit is expensive. You've got to have the drill, the tap, the counterbore, and the Ken here, he knows these things well. He does a lot of automotive stuff. So that's that tool. And then you've got the wire inserts. These are the wire inserts. A lot of you are probably used to these. And each one needs a tool to fit it in. And then they come standard. You can buy kits or you can buy them singly. And that kit will be the STI tap. Here you have it here. The STI tap is what is a standard tap insert. You've got STI written stamped on it. And they can come either in the normal taper, intermediate, or bottoming, or you can get them stepped. This one here, step, I use it extensively in aluminium blocks because it cuts its own thread. You can screw it in to the residual thread and it will pull it and help it hold it steady, and you can carry on and it reams it and it creates the insert thread at the same time. So I use quite a few of those. They're very easy to use and they save a lot of time in drilling and so forth. Now that's another option in the thread repairs. Here you can see it in action with the regular thread, so it's picking up what's left over there, and then it's reaming. And then here you've got one that I've made an extension of. Sorry, that's a long length. You can buy them in long lengths as well. Sometimes, like this STI tap, I couldn't fit it in. There was a place that was too small, so I cut it off and ground it flat on site with a grinder, and I used this to get into that really tight spot to get that to produce the thread. I didn't have enough room to get a drill in it, so this reamer, this cutting ring, is fantastic for that sort of thing. I use extensively these tools. These parallel, let's say thread outputs. They come with a nut like that. They come with a drill, a suit. That's all in your kit. There's 5 or 6 there. You've got the hole, you've got the drill, you've got the easy out, and you've got a nut. And then you can drill that through, knock it down, and the secret of these is not to put it down too deep. You just, in most cases, I'll go in probably that much. That much, maybe a little bit more, very carefully on centre. I'll then put the nut on and I'll try and get that nut as close as I possibly can. And then maybe sometimes even with 2 spanners, two wrenches, one on top of the other, I'll get on there so I'm not applying any pressure to the side. I'm trying to get that to work to its fullest extent without it watering, and then it's not working. Now, if under a lot of pressure that's not working, I abandon it, lock it back into the porch and pull it out. And I go to the next method. These are sold by Rigid or Blue Point, and I've got some of these up to 2-inch diameter. And they also come with a set of, I'm not selling these for them, I'm just showing you a kit. This is a Blue Point kit. Have a look at it. And that's one of the tools that I use. If we go back, so that there, you can see how I've applied it. And this wrench I have is a through hole. It's not like an ordinary socket. It's a through hole socket. And it sits into a ratchet, so it's actually helpful from the outside, not the inside. And that's ideal for this sort of work, where you can slide that wrench all the way down and operate it that way. And you can see it here in an inches, where I've set it up, and I've pulled that thread out. It's just the last thread I've then gone to take it out. There you have it. And there's plenty of them here. You can come and see how you'll see the ridges inside, how I've released it from that. Well, this is threading, this is single point threading, so that's the sort of items I do. This is for oil and gas. It's an 80mm nut and bolt for setting something, so we'll just move on with that. Then you've got the drilling, grinding, and as we said, all those different methods. Here I had to get out pins, 3-inch pins, that long, stuck in these booms. We couldn't get them out, so I had to set up a mag drill, and you can see the length of the drill here that I went down. Then I threaded all the way, then I put a long piece of threaded bar in there with a 60-ton hydraulic hollow piston, pulled those out. And when we couldn't get them out, the ones we couldn't get out, then we had to resort to lancing. These are little pullers. You can see this is a little slide out, 4mm. I make a lot of these for pulling things out. Then we've got these are ones I've made for the oil and gas industry. They are for pulling out mesh. They're a type of mesh, and they can slide those in, turn them around, and pull them out. That's a vice. It's a hydro vice. 100 ton. I repair the jaws of those. That's another one of the jobs I do. Then there's the electric discharge, EDM. In this case, I'm getting some pins that have been broken off, pressed in pins, broken off, high tensile belt pins, and I've gone in there with the EDM and I've bored a hole through them with the EDM and released them that way. There's another one, the spark erosion work. It's dirty, it spits all over the place, but it works well. And that's oxy lancing, a large 160mm diameter, over 6-inch, 5-inch diameter, 6-inch diameter, that long, that I couldn't get out, so we oxy lanced. That's a thread that I had to rebuild from a tool. And then I've got all sorts of things I do, motorbikes, pumps, frames, heavy machinery, and the inserts. Now you've got the wire inserts, that I showed you. Then you've got the time inserts, which I showed you. Now these time inserts also come as a big insert, a heavier wall. That's the big insert, and that has a button on the side. Now with the big insert, it doesn't have to have that counter ball in it. It's just a full thread, and it's got this button, got 2 buttons. When you screw it in my hand, and then when you put the applicator in, it pushes those pins into the body. That's how it holds it. There's the wire inserts versus these. Now, the strength of the wire insert or the big insert is exactly the same. I've tried them both; they're exactly the same. But when you go into the heavier wall ones, that's when you see a major difference in the strength, because you're going out to a much larger cross section. And then you've got the key inserts. That's the ones with a little. We should have one here. That's a key insert. Now there's 2 types. There's a thin wall and a thick wall. And the key insert, you drill and you tap, and these are normally the threads are standard tap. So you don't have to use an STI tap. You just follow whichever thread is needed, and then you screw that in, and then you drive in these 4 pins, and they lock it inside. Some call it lock insert.